Bismillahirrahmanirrahim. Start with the great name of Allah, who is most merciful and the beneficent. Today's my topic is types of reactor, and today I am presenting the presentation. My name is Shazib Sheikh. My roll number is 18 Chemical 36. Submitted to Sir Shaukat Mazari, and my subject is Chemical Reaction Engineering. So now types of reaction. I am discussing about the different types of reactor, and as you know that reactor is equipment that converts the raw material into product by using different techniques, by using catalyst, by using thermal attack or temperature variation. So if anything converts the raw material into the product, that equipment is also called the reactor. So in second slide, मतलब it means that slide number 2 I am discussing about different type of reactor. So there are three types of reactor which are commonly and generally used in all the industries, that are batch reactor, continuous straight line reactor, and tubular reactor. tubular Tubular reactor is also called plug flow reactor. So these are main types of reactor. Here you can also see that the three different type of reactor in bottom of slide, that are packed bagged reactor, catalytic reactor, continuous state reactor. Defined in both cases, packed bagged reactor or we similar to plug plug flow similar continuous straight reactor, catalytic reactor, or very similar to continuous reactor, state reactor. Now the slide number, no, types of reactor. Here you can see in the different type of reactor or catalyst or their own properties. First one is batch reactor. This reactor going to work and continuously change in the reactor into the product. When the product is occasioned, the well reactor, the outer develop is open and the product is discharged. It is uh, closed system and well mixed. And the second is plug flow reactor or open system. And steady state system means inlet flow rate is equal to outlet flow rate, and it is continuous system. So the material balance is very similar in both of this. And it is open system, so continuous flow of inlet and flow of outlet is maintained in the continuous state reaction. Here we can say that inlet and outlet flow were occasion in all the time when the reactor is working. Now the most important thing is that the general mole equation. The general mole equation that satisfy the ideal condition and real condition, as well as it can only say that the input is equal to output. You can say that about flow rate is equals to the output flow rate. If we talk about this equation for the context of reactor, so we can also say that the inner flow rate minus outlet flow rate plus general generation is equal to accommodation, and two variables are added in this equation is general generation. The generation of product means the product are generated in the reactor is termed as generation. Now accommodation is amount of material that are stick in the reactor, that the store in the reactor throughout all the process, that is known as accommodation. These are main general mole equation, and these variables or we can use in all derivations. Fn naught in is inlet flow rate, Fa is outlet flow rate of steam. Generation is denoted as the integration RAdB. R is rate of reaction. D is change in volume. Accommodation is d Na upon dt. It means change in number of mole with respect to the time. Now I am discussing about the batch reactor batch reactor mole balance. Batch reactor, the derivation, the batch reactor, so you can see that can inlet and outlet of the reactor and excitator. That means the reactants change into the product, and you can also see jacketing at the surface of the reactor that can use for isothermal reactions. So talk about equations the batch reactor, so you can also see the general equation. Now talk about the specific batch reactor. A specific batch reactor inlet and outlet is equal to 0. The total inlet of reactor is equal to 0 and total flow of the reactor is also equal to 0. There is no flow, so the above equation can written as integration RAdB is equal to RAV. So integrated on both sides, so we can normally say dna upon dt Ra upon Ra into d. It is general equation of a batch reaction. So the advantages of batch reactors, they are preferred for established kinetics because they are simple in concentration construction, require little or no auxiliary equipment, high conversion, is easy in data collecting for isothermal reaction at constant volume. Now the disadvantages of batch reactors. Number first, preferred for homogeneous reaction, high labor cost per batch for small scale production, difficult for large scale productions, no instrumentation, poor quality of products, taking long time for batches. Here we know that this is CSTR mole balance. Now I am talking about general mole balance of CSTR. The main function of CSTR is hesitation, means the mixing material is very important, and this can also use for increase in conversion, that the inlet and outlet of the CSTR could be open, could be closed. It depends upon you. If you talk about the steady state condition, means inlet equals to outlet, the accommodation is equals to 0, means the all flow rate of inlet is equals to rate of outlet, then condition accommodation is equals to 0. At last, v is equal to fn naught minus fn divided by minus ra. This general equation, this is called the general equation of mole balance of CSTR. Now the advantages of CSTR: it is continuously operation, it conducts a good temperature control, and it is easily adapted to two phases: simplicity of constructions, and it is low operating cost, easy to clean. It means the easy in cleaning. The advantages of CSTR: it is lowest conversion per unit volume. Now bypassing and channeling is possible along with poor agitation. Plug flow reactor mole balance. As we know that the flow reactor mole balance is Fa0 minus Fa plus RSdV is equal to dNA upon dt. Now this is the volume necessary to reduce the entering molar flow rate mole from Fa to the exit molar flow rate of Fa. Polyethylene reactor. This is inner diameter reactor is designed to operate at a 35,000 psi and 60 and 600 in operation. This reactor is in a variety in a vertical configuration. Now this is the plug flow reactor mole balance. And now term is the advantages of plug flow reactor. Plug flow reactor have a volumetric unit conversion. It runs for long periods of time without maintenance, and it is the matlab the heat transfer rate can be optimized by using thinner tubes and its thicker tube in parallel. They have low operating cost. The disadvantages of plug flow reactor. Now it control the poor temperature, and its shutdown and cleaning may be expensive. It cannot control temperature at mid of the tube reactor. Now I am drive the derivation of CSTR design equation. Look at this. We are consideration and secondly we have drawn a figure because I am lecture about this CSTR design equation. Now what is CSTR look like? We have some flow and flow rate was F which is number of moles. Now this is formula is that the dNA upon dt is equal to Fa0 minus Fa plus rho Va upon C dV. Now its equation, how big is of a CSTR is needed. We know that the Fa0 is equals to VCAO. Fa0 is equal to V point VCA. V is equal to N is the corresponding, N is the the place of V, Ca minus Ca upon Ca. Now the formula, our formula is 0 naught is equals to Fa0 minus Fa plus Cav. If well mixed, that Ca is equals to naught Cav, and now our answer is that the Ca minus Ca upon A. That is answer of this derivation. What is example of as we know that the example of CSTR. Here we look at second order reaction in which water reaction the silicon hydride in a steady state continuous reactor, and so make a diagram for information. Let we know that the order reaction first our respect A and W respect to Ca. Now see the hydride state, so no change respect to time. I can write that this terms volumetric flow rate consideration is liquid phase volumetric flow rate change and its constant, and we have reaction in terms of volumetric reactor. My question is that the hydrolysis of acetic anhydride to form acetic acid is carried out in a 1250 L CST, or the CH3 CO2 CO2 O plus H2O uh, converted to CH3 COOH is first order in CH3CO2 and the first order in H2O. At the reactor temperature, the rate constant is 0.075 moles. The feed flow rate is 15 watt is conversion of acetic hydride. Now I have drawn the figure for understanding. So now A plus W is 2B, A is equal to minus KCA, CW, K is equal to 0.0075 upon moles. Now what is CA? What is CA? Ca2 is equal to 2.5 mole, CWO is equals to 50 mole. Now what is Ca? I can write that this term, the volumetric flow rate consideration is a liquid phase volumetric flow rate change and its constant, and we have reaction in terms of volumetric reactor. This equation is complicated. If we solving this if we have solving this equation which have energy balance, it is complicated. So now we have the formula and applying for solution is that 0 is equals to v0 w0 minus v0 cw minus kca cwv. Now term is that data is v0 is equals to 15, k is equals to 66.0015, v is equals to 1250. Ca 0 is 2.5, Cw0 is equals to 50, Ca is equals to 0.03 moles, Cw is equals to 47.6 mole. Now integration of these terms, and we solve that that this way. X is equal to Ca minus Ca upon Ca is equals to 2.5 minus 0.081 upon 2.5 is equals to 0.97. It's our answer. It is an answer that is the 0.97. That's all. Thank you.